Hello everyone, welcome. If you have a Databricks or a data engineering interview coming up, this one is for you. We are going to go through the most common topics that comes up in these interviews, such as the PySpark transformations, joins in data lake and cluster architecture, and so on. So here, this deck covers the core concept you need to know across three main areas: data engineering, PySpark, and Databricks specific feature. We'll look at real code example and explain the why behind each concept and flag what interviewers are actually looking for. This one is the most common thing you will be asked to write in a PySpark interview. The key thing is to understand is that group by alone doesn't do anything useful. You always have to pair with aggregate function. Look at this example. We have an employee dataset with an ID and name and department. We want to group by department and do things that count the employees and a list of their names. So inside aggregation, we use count ID and alias it as employee count, then collect list, name, alias name, gathers all the names in that group into an array, and we call the names. The takeaway here is aggregate lets you apply multiple aggregate function in one go, which is most efficient and a clean method. Next question is about filtering the salary greater than 100K in 2022. So in PySpark, we use filter with column to express conditions in a readable way. Notice that when combining multiple conditions, we use AND operator and OR operator, not OR keyword. That's a common mistake people make. We also wrap the date column with the year function to extract just the year part before comparing. Then we chain a select to return only the columns we care about, are clean, readable, and plain and chainable. Okay. Now let's talk about Spark internals, such as there are three levels to understand. Those are jobs, stages, and tasks. Job is triggered every time you call in an action like show, count, or write. Transformation like filter and group by are lazy. They don't execute until you trigger an action. Each job is broken into stages. A new stage begins wherever there is a shuffle, meaning data has to move across partition. Think of group by or join. Those require shuffle and create stage boundaries. And within each stage, you have tasks. So one task per partition run in parallel across your cluster. So So the chain is action, job, stage, and task. This ties directly into the previous slide. Narrow transformation works with a single partition and no data move across the network. Example, filters, maps, select. These are fast and cheap. Whereas wide transformation require a shuffle across partitions. So and across executor. Example, group by, join, order by. These are the necessary sometimes but expensive. The interview question they are looking for is minimize white transformation wherever possible. Every shuffle is the network cost. If you can filter early and reduce data before a group buy, do it. Next are the common functions of PySpark. They are lambda, map, and list. So this is one example which combines all the three into it. So a lambda is an anonymous function that takes a number and returns its reciprocal. So 1 becomes 1.0, 2 becomes zero point 0.5, and 3 becomes 0.003. So map applies the function to every element in the list. It doesn't compute anything immediately. And list forces the evaluation and gives a concrete Python list as output. Why does this matter in an interview? Because understanding lazy evaluation in Python's map is stepping stone to understand why Spark transformation are lazy too. It's the same mental model. This is a great practical question. Find the most recent job of for employee. So this can be written either with an ACT and a PySpark. Okay. The SQL approaches use a CT with a window function. We use row number partitioned by employee ID and ordered by start date and descending. That assigns the rank to 1 to the most recent record per employee. Then we just filter where Rn is equal to 1. The PySpark equivalent does exactly the same thing. We define a window function and window spec with partition by and order by. Apply row number, filter to keep only rank 1 and drop the helper columns. So if you are asked this in an interview whether in SQL or PySpark, the pattern is same. Window function, rank, and filter. No, both portion is good. Next, one of the famous items of the PySpark questions, that is the joins, optimization, and cluster strategy. Joins are a big topic. Let's break down into four key concepts like broadcast join. When one table is small, under roughly 10 MB, Spark can send it to every executor. No shuffle needed. This is the fastest join type uses broadcast to force it. Okay. Next is sort merge join. The default for large to large joins. Both table get sorted by the key, join key, and then merged. It handles high cardinality well, but involves a shuffle. Okay. Next is the shuffle has join. Spark shuffles both the tables by join keys and builds a hash map. Used when sort merge would be too expensive, less common, but good to know. And finally, we have Z ordering and sorting. The optimization strategies. Z order physically collate related data on disk, so queries skip irrelevant files. And sorting is used when you join queues or skewed queues to prevent hot partitioning. You add a random suffix to distribute hotkeys. Next is delta link. Here we have read, writes, and live delta live tables. So, delta links is a core Databricks topic. Writing a delta table is straightforward, and delta df.write format, delta mode override the save path. Reading it back is just spark read format delta load path. Okay. The powerful feature is time travel. Delta logs every transaction so you can read a previous version of your table with option of version as of 3. This is a huge for debugging and auditing. And the bronze, silver, and gold medallion architecture is the standard pattern here. Raw data in bronze, clean data in silver, and aggregated business data is in gold. And we use decorators dlt.table to define managed pipelines with built-in data quality expectation, lineage tracking, and auto scaling. The cluster types and architecture are also one of the important questions for senior level interviews. So, interactive clusters are multi-users, always on, great for notebook, great for development purpose, exploration, collaborating, and during development, they support auto scaling as well. But job cluster, these are spun up for single scheduled job and terminated when it finishes. They're cost effective and isolated, meaning one job failure doesn't impact the another. Then the MPP architecture, it's nothing but the massive parallel processing architecture is what makes Spark work. The driver node coordinates the work and the worker node executes across distributed partition in parallel. And the Databricks workflow is the native scheduling tool. And you can build multiple task jobs with dependency, retry logic, and alerts on a cron schedule. And the pro tip here is always use a job cluster in production to avoid resource contention, contention and reducing the cost. Never run production workloads on interactive cluster. You will avoid resource contention, reduce cost, and keep environment clean. And that's wrap. We covered group by and aggregation, filter, conditions, Spark internals, jobs, stages, tasks, narrow versus wide transformation, window function, join strategy. If this helped you, drop a like and subscribe. It really does help the channel grow. Thank you. You got this.